Howdy.
Hello, Mr. Josh.
How was your day?
Boring. Somehow not as eventful as I thought it was going to be.
I guess that's okay.
hmm
Mine was just the usual older students that were in the clinic didn't remember their credentials and crap like
Well, you know our motto here: no catastrophes. Good day.
that.
Uh, just finish. Trying to see what one I can actually finish this. Three-man's Morris.
Sure. Kind of surprised there isn't anybody here yet.
I started this early just in case, but I don't expect people to show up until like 5-10 minutes after. Interesting. Let's see. Okay.
Yeah, we're gonna have to investigate that thing I was telling you about the other day in virtual clinic.
The grade.
Yeah, because like students that have a score in a case for this, this term, they show up regardless of course. It's really strange.
Okay, can you send me the list of steps to recreate the issue?
Sure. Like I said, I know that's what I have to do. It's just it's very very, and that's what I keep doing. I keep like checking the checking the scores, checking the course, checking the scores, checking the course. Students to make sure. Luckily, there's a thing. All three courses are all using the same cases, but they have different students in each course, and that's when I realized it. I was like, what's going on here? That's pretty cool.
Pieces back to its initial location. Yeah, I tried to write this first, and yeah, this is the one I realized that because in order for me to do this the proper way, not the shorthand and cheap way, I actually need to set for state transitions. So for this game, I actually need to go through the placing phase, moving phase, and flying phase. And if I want to go ahead and also do the animation, because we got to do this in 3D, there's a pre-transition and post-state. So that means there's now 6 states for placing a player one and placing a player two for each of the pieces, and then it goes to moving for each of those locations.
Have you been following the news about
Ooh.
Diamond comic distributors?
Oh yeah, yeah. My comic book shop is closed.
Yeah, they evidently they were literally, one rent payment around from not being able to pay their bills. Or they are not paying their bills. Because the reason I know about this is because if you recall, all my early video game colleagues were all from the comic industry.
Mm. Yeah, so next week I intend to go in there and try to support the other comic shop, since there are two in here, and both of them are going to die out if there's no participation. Okay, let's see. Come on, no error, still error. Yeah, this is the thing I'm going to go through with the students relatively quick, is this kind of bug fixing, how to detect for issues.
Cool.
Yeah, this game is likely a bit too ambitious.
601. We have one person here.
Hello. Okay. Mhm. I work on this game later. And need to use some standard, basically stock model for this thing.
You rip off a link.
Rip off. This is Link from the what's the newest the Link's Awakening remake.
Cool.
Yeah, being online and voluntary, I don't expect that many people to show up anyway. So that's why I'm recording this thing. Trying to fix this build. I try to give the build some definition, but the complete mess up the lining. This would be so much easier if I attach this to my Wacom. Mhm. All right, let's give it 2 more minutes while I tinker with link. And then I'm just going to go through the entire thing and just use this as uh pre-recorded video.
No. Just a bookkeeping thing. Since you're busy looking at this and narrating it, if I see any questions pop up in the chat, since some people don't have microphones, I'll relay those to you.
Glassy. I think the sleeve is still a bit uneven. Don't know why. Ah, okay. I broke the sleeve. Ha 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 ha. Whoops. Gotta fix this. Gotta fix this in Maya. Curses. Okay, I guess I'll stop recording now. It is highly recommended to start off your modeling in Maya so you can get the base shape down on your mesh. And once you have complete that as a MB file, import that into Murbox or other sculpting tool. So you can now add details into your model and basically make this however you wanted it. Then export the file. Select the as object. Go ahead and export the selected model into a FBX file for better compatibility. MB and MA should still work, but for cross-platform compatibility, FBX is the king. Once your model is done, go ahead and import that into Maya to finish to finish cleaning up the model. There we go. This happens way too often. Else link export. Now save. Okay. For sizing, perspective camera. This model will look incredibly large, but make sure the important thing is to standardize the unit. This is incredibly important once you import things into Unity because in order for all the assets to be reusable, all the assets would need to be standard size so that when you're importing things, you won't be trying to adjust them every other time. So to do so, go ahead and create a primitive cylinder. This cylinder right here, this to the point. This cylinder is 1 by 1 by 2. This is this is what we call a standard unit. This is what we consider as the size of one single human character in Unity. The size, the 1 stands for 1 meter in height, width, actually in width, depth, and height. So let's change the radius to 0.5. So this is the size of a regular human. So now with this character model, I need to, whoops, too much. Make sure it's about the same height as a regular human being also, but because he is the chibi link, I'm going to make him much shorter than usual. So this is approximately the height I want him to be. So go ahead and remove a unit. One thing you want to do is go ahead and delete all history if you don't have animator. If you have animation, make sure you only delete a non-deformer history so that everything can be cleaned up. Also, modify freeze transformation. When you freeze transformation, make sure you freeze all the transform scale and rotation. Freeze all 3 of them so in the model, all of this will be standard size. And the last thing that it's very desperately needed is to make sure your model's anchor is to the bottom center of the model. So therefore, no matter where the character is moving, you'll be moving along the surface. So now this model has been modified. Let's go ahead and save this. Let's go ahead and save this back as a link exported MB file. Okay. The modeling site is done for now. Go ahead and open up Unity. Inside of Unity, make sure you have the version that you are using still installed, because to change your version in the middle of the process will be incredibly difficult and also cause so much more unnecessary headache. So for this, I'm going to be using the 2019 version, the latest. And in order for you to do the 2019 version, make sure you also have the Visual Studio 2019 installed, because that's going to be so much more streamlined if you're using the right version. When you create, if you don't, make sure you click on Add so you can select which version of Unity you want to install. Since I already have 2019, I'm just going to be using it. Create a new project. I'm going to make this a 3D project. Make sure you put your project where you want this to be located for project management purpose. And I'm going to code this project GameDev. So as mentioned in the email, what we're going to be doing today while this is loading is to make a Conway Skin of Life. Conway Skin of Life started out as a sales simulation. So the idea is if you have a group of cells that's the cells follow any biological behavior. They can absorb, they can die, they can eat, they can migrate, they can do all this. So what will happen is if we can go ahead and create an environment where these cells is able to simulate a living environment. At that point, we will be able to basically run simulation on how cell will move, microorganism, how they will behave, and how the animal will migrate. So initially the basic rule is there's a lot of rules, but when you trim it down to is any living cell with 2 or 3 neighbors will survive. In other words, unless unless the living cell have 2 or 3 neighbor, it will not survive. Any dead cell, empty cell with 3 living neighbors will become a live cell. The idea is if a living cell only have 1 neighbor, then it will die from isolation. If a cell have 4 or more neighbors, it will die from overcrowding. And if there are exactly 3 cells in a adjacent to an empty space, they will procreate and create a new living cell. That is the most basic rule. So So when you have when you have cells in this 5 formation, they will live in harmony because everything balance out and nothing will change. But if the cells are in these formations, essentially they will just bounce between the 2 states. And some other formations, the cells will migrate because the death and birth will make them so. Okay, so to start on Unity, make sure you set up your layout the way you want. So by default, Unity have a hierarchical structure here, inspector here, project and console on the side with sync in the middle. I'm used to Visual Studio style, so I created my own style with main window here, console here, hierarchical structure, project, and inspector. So global light, I'm not going to mess with it. The camera, the main, whenever possible, always attach everything to the main camera because there should only be 1 main camera in the scene, and there will always be the need for at least 1 camera. So whenever you have any kind of project and any kind of things you want to work with, make sure you attach it to the main camera. To start out, go ahead and create all the folders you'll need. Let's say model, script, uh, texture. Let's see, prefabs. So the first thing to do is always creating a tester before you write anything. In Visual Studio and in Unity, you have 3 options in language: JavaScript, Bool, and C#. It is highly recommended to use C# as right now it performs far better than the other 2. So I'm going to use the C# script and I'm going to call this global. The first thing first is to create a global library. So with that in mind, I would not be needing any of the start, update, awake, late updates, any of the behavior. So I would not be needing this to inherit from mono behavior. I'm going to create this as a global library, document this as a global reference class. And for this class, so far I only need 1 method, public static string to debug. So whenever I have anything I want to do, I can just write to debug. I'm giving an optional parameter of its error. If its error is true, that means this is an error message. So I want to write out things differently. And this is a pet peeve that whenever you have any kind of method, you should always return some sort of data type. I know that school tell you to use void if you don't want to return anything, but just for confirmation purpose, I'm going to be returning echo the message so I can give confirmation something's working correctly. In order to use things in the Unity script, make sure you have Unity library included. And in order for Visual Studio to work with your Unity system correctly, make sure you can see this attached to Unity button on the top. If you don't, go back to Unity, change your preferences, change your external tools, change to your version of Visual Studio, and make sure you allow for editor attaching. If you have this checked, this button is still not on, turn it off, turn it back on, and restart the project. Once this part is done, you can then do debug.log, and I'm just going to write out message right now. So what this allows me to do is I now have a global library, no compiler issue. I'm going to be creating a main script. The naming doesn't matter as much, but as a part of C-based language, you always start with main. So in this script, I'm going to be sectioning things out. Public config variables, private data holder variables, getter and setters. Creating this template so codes will be much easier to be organized later. Constructor. Frame update code goes here. All helper method goes in here. So what Unity does wonderfully as a part of its model behavior is when the project starts, you will try to instantiate all the objects. At that point, a wake method will be called. Then once the object have been constructed, when the script is first started, you'll be calling the start. So just to test things out, I can now do global.toDebug hello world. By doing so, I should be able to attach my main script to my main camera, save. When I run this, I should be able to see hello world. That's exactly what I want. And now let's go ahead and add additional features. String.format. Rather than just writing information out, I can set color as a part of Unity specialty. So in Unity, what you can do is set a color tag like HTML to whatever you're going to write. Whoops. The first one would be the if this is an error message. Actually, if error message is, since I'm using a tri-state the Boolean value, so Boolean could be now nullable. So if this is null, this is going to be a regular color. So I'm going to be using the default black color for font. Otherwise, if this is indeed an error message, then I'm going to be, actually I don't need to do this. I can just typecast is error. If this is indeed an error message, I'm going to be using red for the font color. Otherwise, I'm going to be using green for the font color, and then write out message. This will allow me to say this is a error message. This is a success message by giving different ending parameter. So now when I start again, I should be able to see 3 different messages: default, error, success. With all of this being color coded, you should be able to see this your messages much clearer instead of everything being boggled down. And of course, with Unity, you can just use descriptor for your color. Okay, with that out of the way, I can now go ahead and start up on creating a tile as a part of the Conway's Game of Life is still a tile-based game. So what I want to do is now create an interactable tile. These tiles, I'm going to call this a marker. Let's go ahead and create a 3D object, a cube. And I'm going to pretend that this cube is an object that's interactable in the scene. And I'm going to call this marker so that turn this into a prefab. So now in my main method, I can go ahead and set up a reference to what I need. Public vector to int, because I want this to be an integer value, not a float point notation. The size of the map equal to new. Let's say that start with, by default value, I want to use 10 by 10 as the size of the map. This is important as for the programmers. You always want to show tooltip on what this value is, size of the map. And then I would need a multiplier for speed. Frame clock multiplier. And this is not necessary, but in order for you to reuse your code, it is very convenient to set the value for multiplier had to be somewhere between 0 to, let's say, 10. And when the scan starts, I can then go ahead and create the reference to the prefab that I'm going to be using. So now in Awake, I just need to always perform verification. If the verification is not completed, then don't start the script. So I need to have a value to say whether or not initialization is being completed correctly. Yes, correctly initialized. Okay, that's why it looks wrong. I'm going to assume initialization was completed successfully until proven otherwise. And this is why I'm going to prove it. Verify settings. And the first setting I'm going to check is to make sure the map is at least 5 by 5. So if size.x is less than 5 or size.y is less than 5, then I'm going to say, nope, there's going to be some problem. Global.toDebug, unable to start again with below minimum size of the map. I'm going to mark this as an error message. Mark initialization failed, And I also want to make sure the marker is being set correctly. Need a reference to position marker prefab, and it is indeed an error message. So now my main script have this component as set in the public variable size, multiplier, marker. The private variable initialize will not be shown here. And because I have set range on the multiplier, so you will only go between 0 to 10. You always want to set this up, have to have initial value. So does any of this size. So now, because when you mouse over, it will tell you exactly what you need for any of these attributes. For the artist in the audience, if you ever use someone else's script and then it doesn't work, 90% of the time, they require some sort of reference that you didn't provide. So now, if I go ahead and start again, since I did not provide any marker, I should receive an error message. Indeed, I need a position reference to position marker. So I'm going to add the reference of prefab, drag into the scene, and now it's not complaining anymore. So now when the game starts, let's see, what I'm going to do is if it is not initialized or initialization failed, I'm not going to do anything any further. And cannot stop because it was not initialized correctly. And go ahead and disable this script so nothing will run from this point on. So I'm going to define how I'm going to initialize this map. Again, always have a return value to show whether or not initialization was completed successfully. So now I'm just going to create a cache for my map, because if the map size is in the global variable in the public side, people can change it on the fly. So what I'm going to do is I'm just going to be creating a copy of it and save that into my private data holder. I'm going to call this map size. So as a part of initialization, I'm going to make a copy of the map size. Initialize my grid. Map size is equal to size. From this point on, I'm going to be using the copy. So I'm going to be doing I'm going to create a grid of the prefab by making it map size minus vector 2 1 divided by 2 to have an offset. I'm going to have a temporary holding reference called temp. And I'm going to loop through the map size. Actually, let's call X and Y. This will loop through every single X coordinate, and I'm going to loop through every single Y coordinate. now, once everything is initialized, loop through, I can now go ahead and instantiate a place marker to the state coordinates. So 10 is equal to again object instantiate the prefab the new location, and I'm going to in Unity scene. Z is forward, X is right, Y is up, and I'm using XY rather than ZX. So I'm just going to be translating that a bit. So the X location, I'm going to keep the same. Y, I'm always going to be using 0, so everything's flat. And I'm going to be using my Y value for Z. And by default, does it identity. I don't want any kind of rotation. The new map object will be the name will be its location, and okay, this. Oh yeah. Okay, now when I start again, I should see a grid being initialized based on the size, and that's going to be the exact same marker object. Marker 0 through 9, 0 through 9. So this is exactly what I want. Now I want to give it some more interactivity. So for these markers, I'm going to make them as their own separate object. For the markers, whoops. I don't need this thing to run on regular updates, and I only want them to react when I interact with it. So I'm going to have a public interface method region. That way, I can do void on mouse up as a button. So by default, when you interact with Unity 3D object, you can put a hook on mouse up and mouse down. But if you want to have a hook on both up and down, you go ahead and just set this up as both. So activated on mouse click. So what I'm going to do right now is just to confirm that this is working correctly. Global.to-debug. Click on this .NET. So now whenever I click on any of the block, I should be able to see message pop up saying that I have clicked on its name. Let's just on the camera a bit. Okay, now when I start, whoops, in region, misspelled. Okay, looks good. Copy component. So now whenever I click on any of the block, Slider. Oh, I haven't attached the marker. Haha. Now the marker is a part of the prefab. So now whenever I click on the click on the block, it's value. You should now tell me which block I'm currently click on. 00, 09, 90, 09, 99, X, Y. Okay. So now for rather than just read on its name, I also want to remember what this object is. So public vector to int location. I want to know where it is. The cell that's inside of this location, and whether or not this cell is currently alive. Now you can go ahead and modify the prefab by double clicking on the prefab. So this is how the prefab will look like, but I don't want the box to be shown because I just need it to be clickable. I don't actually need it to be seen. So what I'm going to do is create a new 3D object in there, just a tiny sphere for the size of 0.1 to 0.1 to 0.1. I'm going to use this as position marker. So therefore, this is still clickable, and you can see where the center of the location is without this entire box being there. Save, double check. So this is working as expected. Now for each of the marker, I want to create a separate object so I can have something to look at. And that's where the previous model I work on comes in. So I'm going to make a copy of link, drag that into my models. The importing process may take some time depending on your GPU capability. This is longer than usual. What Unity does is whenever something can be imported, it's going to pass that through so it can be in a cached format. So I'm going to create a folder for this. This is going to be the location for link, and I'm going to also import link's texture file as well as the normal map. So now I'm going to drop link. Oops. When you import for the normal map, always change this setting to normal map. So do not generate this from grayscale. Now I can go ahead and add link into this location. Since my camera is looking in this direction, rotate 180, so link can be looking at the camera. So for this link, whenever you have a model, I want to import the materials, but since this is just static model, I will not be importing any animation since I didn't create any. Since this is just something to look at, I did not rig this thing. Turn off the animation type. So now go ahead and re-add this. It can be much cleaner. So now for this mesh, this is the material I'm using. And this material, I'm going to be creating a new one just for link skin. And link skin is going to be using my texture file. It's going to be using my normal map. And I'm just going to be dropping this onto link. So, rotation 180. So now this this is how link will look like in the scene. Actually, this smoothness, let's go ahead and turn it down a bit so I can. So the slash shine. So now this is my location marker, and I'm going to treat this as the center of the cell. By default, I'm going to turn this off because in my script I mentioned the cell is not alive by default. So now when I start again, I turned off the wrong one. I'm supposed to turn off link and add link to the cell. Okay. So now I should be able to see the grid, but I don't shouldn't be able to see any link. Idea is if I go ahead and click on this cell, this location will be alive, essentially creating a toggle, alive or dead. And then whenever something is alive, you will see a link. If you don't see a link, it's dead. So to do so, I'm going to use a callback method. To use a callback method, then I'm going to be defining this in the marker location, since that's actually I want to define this in my main method. Inside the helper region, I'm going to define a delegate method. Probably. Delegate method itself is a very huge topic, so I'm going to skip the explanation on this. Just know that I'm defining a dynamic method type. It's going to be the type of location. Location is while location is calling. Now I have a location type. I can go ahead and make sure that my marker have the corresponding callback method associated. Public main the location callback function. So far is equal to no. So now rather than whenever I click on it, it just say it has been clicked on. I'm going to remove that for now and say if there's no callback, global down to debug, click callback not initialized. It is an error message. But if the callback function does exist, I just want to call that function and give it my current location. So now whenever I instantiate each of the game objects, I can now go ahead and find a reference of let's see, how do I want to do this? Generation okay. Marker X is equal to no. So I'm going to whenever I create this map, I'm going to be adding that to my local reference. So I can, instead of coding out every single time, I can just have a local map location for it already. So I'm going to be doing a private bool two-dimensional array data private marker two-dimensional array cache. So now whenever I generate the position marker, I can now go ahead and add reference to that data. Actually, if I do that, I want to initialize the data first. A two-dimensional array of map size dot x plus 2, map size dot y plus 2, cache is equal to new marker map size dot x dot y. The reason I have plus 2 is to save some CPU time. And location callback. So now whenever basically I'm going to give this a one by one margin all around the size of the map for later on. So data of x plus 1, y plus 1 is equal to, let's go ahead and say by default this is false. this object is not yet alive, but I can now cache the object that was just created, the temp. But I don't want just temp, I want temp's component, the component of marker. And now that I have a reference to temp's marker, I can go ahead and reference to each of the marker object, set a callback function to my callback, set its location to x.y. So now I need to have a interface function. So I'm going to be probably interface method. Location clicked. Which location has been clicked? So whenever an object been clicked, I want to toggle its status. And because I also keep a local cache on whether or not a cell is alive in local location, so I can update both at the same time. Which location was clicked? So I can now toggle the data. Cache of location.x, location.y.alive. Forgot to set in the marker. So now whenever to make this more easier to use, I'm going to create this as a public setter and getter. On get, I'm just going to be returning the alive status. But on setting this one, toggle cell display. So now if the alive value is not what I want to set it to as simple verification, I'm going to set the alive value to be whatever the value is. It was set the current marker's alive status. So now whenever semicolon. I never actually finished implementing this side. Okay. So now the alive is available, and that is now the same as data of location.x plus 1, location.y plus 1, which is just toggling. So whatever the data is, I'm just going to negate it. So now whenever I click on whenever I click on any of the marker, it's going to call the callback. The callback is going to say, hey, whatever it was, negate it and set it back to the location, which the alive status will toggle its alive status. What did I say? There we go. So now whenever I click on any of the location, you should be able to see the cell being toggled on, off. And to do this manually is quite tedious. So what I'm going to be doing is to create a randomized method. So it will do this for me automatically whenever I have the game started. So I'm going to be creating a new Contra script. Contra was originally created to help user debug the system. So that's why I'm going to be using it rather than as cheat code. Using the same delegate method style as before. Callback X equal to no, and setting up the private data variable. So what I'm going to do is using a contra index, I'm going to have an array of key code called the contra code, which is key code array. I'm going to set a value and this needs to be public. Index start out as 0. So I'm going to set the key as key code dot up arrow up down, whoops, down, left arrow, left, right, left, right, B, A, return. So now on the frame update, I'm going to declare the delegate method in this location. I'm going to have a contra callback data type of no input value. So now whenever the game is running, whenever the game is running, I'm going to check to see whether or not any key has been held down or pushed down. If the key is being pushed down, I want to see whether or not the key that's been pushed down is the same as contra cost index. So if the idea is if it's the same key as I'm moving forward, that means people are putting in the right key. So if it's not correct, then they did not put in the correct code. So increment now the user, but if the user did not put in the correct key, then else reset the index. The idea is I'm going to be pushing index forward until I hit the end of the code. Hit check for end of code. If index is greater than or equal to contra dot length, and there is callback method to use, what I'm going to do is call the callback method and reset the index back to 0. So now I'm going to attach my contrast script to my main camera. So when my main camera is initializing, it can go ahead and pick up the existence of contra code and those let's see. Okay, on my initialization, I go ahead and associate contra handler. Create a reference to the script game object, current game object, the get component. I'm going to grab a copy of contra component, and if contra component do exist, then then the callback method is going to be, let's say, randomize map. And now I'm going to say what randomizing map is. So I'm going to define that in the, what's my helper method? Helper method. Current map. So so what I'm going to do is just completely randomize every single object in the scene. System random variable x. I'm going to again loop through the entire map. And I'm going to create a random value for it, for the map. So back to the top of the, so what I'm going to do is the data of +1 of y plus 1 is equal to cache xy dot alive status of, I'm going to use a random number generator to randomly give me a number, and if this number is greater than a, let's say, random hit value, then it's going to be true. There we go. So now I'm going to set random hit as a part of my configuration. Let's say 0.45. So to tip probability of a cell being alive in a randomization. And I'm going to be setting the probability of randomness from 0 to 1. Okay, no issue. So now when I start again, whenever I put in contract code, the entire map should be randomized. Up, down, down, left, right, BA, return. The boundary, why? That's because I haven't finished caching this yet. Get component, go back. Why is this? Index outside of its bound, randomized map update. Cache XY. X0, X1. Let's see. It looks like when the x is equal to 0, everything's working correctly, but when y is greater than 0, it's not working. Yeah. Okay, now it's working. Up, down, down, left, right, BA. Up, down, down, left, right, BA. So now I can randomly generate a map without having to manually do any of the work. So now I'm going to set the size to 20 by 20. Left, right, BA. Good. So now with the map size, without the ability to create an object, remove an object, and such, now the meat of the game comes in. So on the frame updates, a very standard clock cycle, what I'm going to do is on the private number, what's my private variable? I'm going to create a timer. Cost equal to false. Flow accumulator equal to 0.0. Flow threshold equal to 1.0, and I'm going to be setting that as a constant value. So now on the update, it's going to be performing some verification. If I am paused, do nothing. Otherwise, check for update event. Accumulator is going to be adding how long has been since the last frame update times the multiplier. So the higher the multiplier, the more number I'm adding. If the accumulation is greater than the threshold, then I'm going to use the turn from Conway's King of Light. I'm going to advance the generation. And once I have advanced the generation, accumulator now reduced by the threshold. So now I'm going to implement the meat of the project, private void generation. So now update the generation of cells. So whenever you perform a lot of tests, you don't want your first test to be still working while the timer is still on. So what I'm going to do is lock the timer, pause it for a moment. In the end, release the timer. False. And since I will be doing randomization, I'm also going to lock the timer true and then release that after I have performed my randomization. And this is what we in OS call the semaphore. So now in this generation, I'm going to pre-calculate the map to see how many living neighbor each cell has. So first, I'm going to create a summary map, and it is going to be the same size as my buffer. The reason I use +2 to the map size is because, well, let's say right now, if I want to check to see whether or not this particular cell is have the number of its living neighbor, I need to check to see whether or not it's on the left edge, because if it's on the left edge, there's no neighbor, it will cause an error. Is there a neighbor on the top left corner? It's also going to cause an error, so on, so on. So that means every single cell that's on the edge is going to cause some sort of problem. So that means in order for me to do so, I need to perform a verification to check to see it's not along the edge. So to do so, it's going to cause additional computation time. And that is the kind of computation time I now wanting to do. So what I'm going to do is instead, I'm going to waste a bit of the memory rather than CPU time. I'm going to pretend there's additional cells along the edge, which contains absolutely nothing. So now, if I go ahead and calculate the number of its neighbor, I can always count on every single location I'm actually using to have exactly 8 neighbors surrounding it. So that's why I'm going to use the size of +2. So for int x equal to 1, from 1 to mass size dot x. So rather than from 0 to the map size, I'm going to be doing the 1 to map size inclusive. and I'm going to look through its y coordinate as well. And now I'm looping through every single one of this. So I'm going to check if the cell is alive rather than checking for every single cell's neighbor. So what I'm going to be doing is a very cheap way out. Rather than check for every single cell, check to see how many neighbor it has alive. In which that means for every single cell, I will need to be checking 8 times. So the total operation will be 8 times n. Whereas if I go ahead and do things in reverse, for every single cell, if it's alive, I'm going to be updating, I'm going to be telling all of its neighbor, hey, the number of your neighbor is alive is going to be 1 more now. So I can drastically reduce the computational time from the size of the big O of n to the big O of log n. And if I don't use the map size of the +2 and I need to check to see whether or not there is a neighbor size, then the big O will be n log n. It's going to be even slower. So now if the data says in a location x, y, this cell is indeed alive, then I'm going to say the sum of x plus 1, y plus 1. This cell, the top left corner of it is going to be plus in the top left corner. You now have one neighbor that's more alive. Left, bottom left, top, bottom, top, right, and bottom right. So basically, I'm saying all the neighbors go ahead and increase the size by 1. Now that I know all of the neighbor size, update the alive status. So rather than making hard coding this, I'm also going to make this dynamic. Public vector2 int life range equal to new vector2. Putting this in configuration. That means from the rule of the game, if a cell have 2 to 3 neighbors, it's going to be alive. If the a cell have anything less or more than that, it's going to die from isolation or starvation. So I'm going to create another range for reproduction range, which in this by the rule I can only have 3 and 3. So document this. Tooltip. Any living cell within this range, inclusive on both ends, will stay alive. Tooltip. Any dead cell within this range, inclusive, will reproduce. So now I'm able to use those rules to say, go ahead and use the exact same loop from before. Okay, now if data x and y is true, that means cell is alive. Check for isolation or overcrowding. Otherwise, if cell is dead, check for reproduction. If the sum in this location is less than living range dot x or y is greater than living range dot y, I'm going to say data of x and y is now dead. So I'm going to be updating both variables at the same time. Now I'm checking to see whether or not if this location has reproduction range dot x, it have at least this much neighbor who's alive and sum of x, y, and it's between this range. I'm going to say this cell is now alive. So now let's go and test this out. No error, good sign. So now I'm going to reduce the multiplier down to 0 so the clock doesn't move at all. So if I only have one single cell that's alive, let's go and restart the clock. It will die. If I have two start clock, both of them will die. But if I have four, like the block still alive location, once I turn on the clock, they should still remain alive. But if I introduce a new cell into it, whoops, didn't do that. So if I go ahead and do contract call, once a second, the gain of life will create a new generation of cells or destroy them. So the idea is if you can go ahead and set up the environment on how long the cell is going to stay alive, what's the living condition, how long before it dies from isolation, how long before it dies from overcrowding, and what's the condition for it to overproduce. You can, in theory, use this to produce a estimation or prediction on, let's say, the migration of koalas. You're going to see exactly in how many generations that they are all going to be dying out, or they're going to be sustaining for how long. And let's go ahead and see what will happen. Let's go and reduce the timer down to 50% of the time. So it's going to be updating once every other second. So now what will happen if I go ahead and be menacing, injecting a new cell into the equation? How will that affect the migration and the living situation of this organization? If I go ahead and remove one out of the equation, oh, how it's going to be affecting the location, how this cell will move around. So this is what we call the gain of life. The bottom one. Okay. Ha 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 ha. The camera is not all the way rotated down, so not seeing the. Copy. Okay. Now you're able to see the gain of life in action. So this is the basic idea of the gain of life. So, but that's not really a game per se, because you're essentially just looking at simulation. So so if you're using a really, really old computer, if you're using Windows 95, King of Life was actually one of the games that was included when you install your OS. So rather than this just being you're looking at something, so what we can do is make that turn-based. Every single turn, you can decide to make one additional cell or kill one additional cell. So the game does not proceed until you make an action. And since we already have an event handler on what happened when any location has been clicked, once this location has been clicked, toggle is data. Then rather than just wait for the clock to tick, I can go ahead and temporarily pause the clock to, let's say, trigger the turn generation. Since it is a method I can call, so therefore I can go ahead and turn off the clock, make sure the clock doesn't run at all. So now, up, down, left, right, BA, I can generate a random map. And now, oh, 0.45 is way too much. So now I can go ahead and make one click on any of the location. Then then the game is going to proceed to the next phase, next generation. Okay, this two is fine, but this one is isolated. I want to make sure this one stay alive. I can go ahead and introduce a partner to it. I can go ahead and try to connect this together. I can try to bridge these two regions together. So now, this is how the game is played on Windows 95. The idea is to see how long you can make this species stay alive. For every action you take, for everything you click, you can try to make sure they survive for as long as they can. This side is a little undercrowded. This side is fine. This side is overcrowded. So sometimes you might need to take out a living cell in order for the greater species to survive. And you can always turn the clock back on to see how it affects everything. And just for the heck of it, I can go ahead and make the clock speed much higher to see exactly what will happen in distant future. 6 times the speed, 7 times the speed, 8 times the speed. So this is how you can make an entire game from scratch of Game of Life. You can make this into a simulation or a turn-based game. Now that they are quite pitiful, let's go ahead and see whether I can connect this together. And now this side is doing much better. Let me see whether one I can connect these two wandering regions together. And there we go. Connect them together. And now I'm going to see what will happen if I go ahead and let it be on their own right now. So this fundamentally is the Conway's Game of Life. Okay. Any question or suggestions? Of course, if you have some animator who is willing to work with you, actually the 4.45 is still way too much. Let's reduce this down to 0.285. The other way around. Okay, look better. So if you have someone who is willing to work with you, instead of just using random link model, you can very easily go ahead and have all of these creatures be moving around animated. And looks like the schedule time is up. So feel free to email me for the code or ask questions via email. My email address is chenk, CHENK @ecu.edu. Okay, I guess that's it for today.
Thanks, Quan.